So, hi everyone. Today I am excited to walk you through the code of a VS Code Copilot extension, which I have developed. This extension integrates advanced language models like Llama 3.1, OpenAI's GPT 3.5 Turbo, and Gemini 1.5, providing powerful code generation and suggestion capabilities. Now, let's quickly dive into the code. So here we are. So first, let's take a look at the package.json file. And this file is very crucial as it defines the metadata for the extension, including its name, version, and dependencies. The name is set to code suggestions, as we can see, and the version is set to 0.0.1. The engine section specifies that the extension is compatible with VS Code version 1.92 or higher. Under contributes section, we define a extension.openChat, which is responsible for opening the chat interface where users can interact and deal with the AI regarding all their queries. Now, let's move on to the script section. The script section, on the other hand, includes commands for compiling TypeScript, linting, and testing the extension. We have also defined dependencies like Axios, for making API calls, and dev dependencies for TypeScript, linting, and testing tools. Now let's move on to the extension.ts file. Okay, so this is where we define the core logic of the extension. We start by importing necessary modules like VS Code and Axios. Now, to start with, we'll start with the activate function. The activate function is the entry point where the extension is activated. Here we register the command extension.openChat, which creates a new web view panel when triggered. For example, when somebody clicks on the or when somebody tries to open the extension, they will basically click on the extension button. So after clicking on the button, the the it will trigger the AI Copilot to be loaded on the right side of the VS Code. That is exactly what the activate function is all about. It you know registers the command extension.openChat under which it is defined, which then further creates a new web view panel when triggered. Now, next we'll move on to the API calls functionality. So, yeah, one of the most critical functions in this extension is the get code snippet function. This function takes a user prompt, sends it to AI, and makes the API call and returns a generated code snippet on the window. We use Axios to make post requests to Together.ai, sending the user's prompt along with specific parameters like max token, temperature, P and K modules, and repetition penalty to control the response and how the response is generated and the type of response which is generated basically. The API response is structured according to AI response interface, which helps in extracting the content from the response. We also handle potential errors gracefully by ensuring that users are notified if something goes wrong. Now we'll move on to the execution part where we have actually, defined the commands npm run compile and code extension development and the development path. So yeah. So before that, just one more thing is that so this is how our backend of the AI LLM code extension works. Now in the front end, the web view content is defined in the get web view content. Okay. So here we have defined the HTML, CSS, and JavaScript to create a chat-like interface where users can type the queries and receive AI-generated code snippets. The UI features an input uh, field, a send button, and a drop-down list for model selections. Users can choose between models like Llama, GPT, and Gemini, depending on their needs. I have also added styling to make the interface visually appealing with a dark theme that complements to the VS Code environment. Now let's finally move on to the execution part. So for execution, we have to define and run the command npm run compile in our execution folder where we have created the extension file. So to quickly demonstrate, I'll once again copy and paste this command npm run compile. Okay. So yeah, after this, our system will start compiling these files, and yeah, thereafter to open our development host window, we have to code. We have to type code and the extension development path under which our extension is created. So let's quickly copy and paste this code here. Okay. So after this, whenever I press enter, a new screen will appear with our extension host loaded. So let's move on to that. So yeah. So as stated, a new screen appears with the extension development host loaded into it. Okay. And yeah, after that, we'll run a command by which we have defined our LLM Copilot extension. For that, we have to go to the show and run commands option. Now here, after that, we have to type the command which we have defined. So here I have already defined and recently used this command. So I'll just click on it. And yeah, so thereafter, Chat with AI window appears on the right side of VS Code, which is basically our Copilot instance which we have created. Now we'll test the Copilot instance. So for testing purpose, I have designed a few questions for which we can test the Copilot and its ability to deal with various responses. So first is a Python code with bugs. So let's see how it performs the debugging functionality. So this is a code which have mistakes and errors in it. I'll just quickly copy paste the code into our development host, and we'll tell our Copilot to debug this one. Debug the code. And then click on the send button. So yeah. So the AI has generated a response, as you can see. So yeah. So this is a code which had errors previously, and it has identified the errors, like the base case for the factorial function was incorrect. Yeah. So it has to be return 1 instead of return 0. We have previously written here return 0, which is incorrect. It has to be return 1. Whenever a factorial of a number is 0, it should return 1. Okay. And it has also stated the answer by a comment side by side. Okay. So yeah. And the second mistake was the function name was misspelled as factoria. Yeah. It correctly identified the error that the factorial name was spelled wrongly. So yeah, these were the two errors, and it has correctly identified the errors. And it has also generated that this code should now correctly calculate the factorial. That means all the errors have been debugged successfully. Now, yeah, so first question is done. And now let's move on to the second question. Second question is about code for testing hard problem, like how it's able to generate the solutions. So I have defined the statements here. So this is the statement Python code to find longest increasing subsequence. So we'll just copy and paste it into our development window. And we'll tell it to first debug the code and thereafter find the longest increasing subsequence. We'll copy and paste. So first we'll tell it to debug the code if required. Debug. First debug if required, and then find longest subsequence. Find longest subsequence. So we are ready with our prompt, and we'll just quickly click on the send button. So it has generated a response. So here it is. So here's a corrected code with some improvements. So yeah, now it is properly visible also. So yeah, so here's a corrected code with some improvements for better readability and performance. So as we can see, it has made the changes which were required, like added a doc string, improved the variable names, used a more efficient approach to find the list named array, and improved the code formatting for better readability. And now the code should work perfectly fine. So yeah, so this question is also done, and further we can investigate the details here as well if required. And so let's move on to the next question. Now we'll move on to intermediate DSA problems. Like, yeah, the question one is about implementing a function that takes two string and checks if one string is anagram of the other, and the second is a array of integers which returns indices of two numbers such that they add up to a specific target. We have to assume that there is exactly one solution. So yeah, we'll take this question as our prompt and we'll paste it into our development host window. Now let's click on the send button and we can see that the two problem solution is also done. And this is the explanation which our Copilot has generated. And it has also generated an example use case for better convenience of the user and for understanding purposes as well. So as we can see, for each number we calculate its complement and it has also defined the variable name with respect to the target sum. And like this, we finish iterating over the array without finding a solution. Then we will return none. And example use case is also given. So this was the second question and it has successfully generated the solution. Now let's move on to the coding problem, which is a tough DSA problem. Let's move on to the tough DSA problem first. Let's see how it is able to generate the solution. So the problem is the minimum cost to connect all points. We have defined the description of the problem and we need to return the minimum cost to make all the points connected. And all the points are connected if there is exactly one simple path between any two points. So yeah, let's copy and paste this code into our window and click on send button. We can also see that it has developed a Python code solution using Kruskal's algorithm to find minimum spanning tree of a graph. And here is the here is the solution of the problem. And also we can see it has also generated example usage for this question as well. And we can clearly see that it has generated a diversified and detailed solution catering to all the needs of the user. Here we have defined the how the PDF, how the extension is actually working. Now let's get back to the question PDF. Okay. And here I have also taken a theoretical question to test how it actually applies the theoretical knowledge into the user prompts. So we'll describe how dynamic programming is used for optimization purposes. So now let's quickly copy and paste it into our chat window. So let's see, let's click on the send button. And yeah, so it has again generated an extensive response. So our question was describe how dynamic programming is used to solve optimization problems and also provide an example for the same. So it has first defined the method for solving the optimization problems. It has first given a short definition of the dynamic programming, what it is and how it works. Then it has defined the key characteristics of dynamic programming as asked in the question. Okay. Thereafter, it has also given examples of Fibonacci series, recursive solution series, and so on. So now also in the while concluding, it has mentioned what it has used and how it has used and what is the effect on time complexity as well. So this is the way how a theoretical question is answered by the LLM Copilot extension. And thereafter, we can use this Copilot extension to test multiple other solutions as well. So quickly, let's move on to question one as well. So problem was to implement a function that takes two string and checks if one string is an anagram of the other. Now let's quickly move on to the extension development and paste it and click on send button. Now we can also see that it has developed extensive solution for this question as well. Now anagram checker function, first it has defined the function and thereafter written extensive Python code to solve this problem. And yeah, so that is how the Copilot extension is working smoothly and it is catering to the needs of the user as per the prompts given. So yeah, so this script actually, whatever the JavaScript, TypeScript, and which is used for making the Copilot defines a comprehensive overview while being concise enough to best cater the user's need. This Copilot extension is designed to significantly enhance coding productivity by leveraging the power of advanced language models. Now, whether we are generating code snippets or solving complex problems, this extension has got every aspect covered. I hope this walkthrough was insightful and if any questions or feedbacks are there, Please feel free to give suggestions. And thanks very much for watching this documentation. And hopefully after this, I'll be able to develop the copilots more extensively with the help of the feedbacks given. And thanks a lot for giving me this opportunity to develop this copilot for Coding Junior. Thanks. Thank you.